9.1 notes, solving trigonometric equations with identities. This is page 1. So we're going to start with a review of some of the stuff we've already looked at, okay? And we are going to use what we know to verify identities. Remember that an identity means the expression, the equation, is always true no matter what value we put in for the variable, okay? So we've got a review up here. This box gives us all the Pythagorean identities. We've got sine squared theta plus cosine squared theta equals 1. We can rewrite that by dividing everything by sine squared theta as 1 plus cotangent squared theta equals cosecant squared theta. We can also rewrite it by dividing everything by cosine squared theta as 1 plus tangent squared theta equals secant squared theta. Okay? So exercise 1 asks us to prove that 1 plus tangent squared theta equals secant squared theta. So we're going to actually verify this Pythagorean identity. I'm going to start always with the more complicated side and see if I can simplify it down to the side that looks a little less complex. So I'm going to start with the left-hand side here, okay? I know that tangent can be written as sine over cosine. And so I am going to start with that. And I'm going to go ahead and keep it lined up under that left side until I can simplify it so that it looks like the right side. So I have two numbers that I want to add. I can't do that until I have a common denominator. And so I'm going to multiply the 1 by cosine squared theta. And since I wrote super big, let me see if I can shrink this down so I can get my last line in underneath there. Perfect. Okay, and so we've got that common denominator now. I can combine our numerator there, cosine squared theta plus sine squared theta, that's the very first Pythagorean identity. That's going to equal 1 over cosine squared theta, which is secant squared theta. So we want to get to the point where we can show that that left-hand side equals the right-hand side, and then we are done. So the bottom part of the page here, we've got reminders of all of the stuff that we've looked at up to this point, not all of it, but a lot of it. So we've got our even-odd identities, our reciprocal identities, and our quotient identities. We want to be able to put together all of those to be able to simplify expressions. So let's take a look at A. We've got sine of negative t times cosine of negative t times cosecant of negative t. I'm going to start by using the even and odd identities to rewrite this. Sine of negative t equals negative sine of t. Cosine of negative t equals cosine positive t. And cosecant negative t equals negative cosecant t. I have a negative times a negative, so I know those cancel each other out. This expression should be positive. So I've got sine of t times cosine of t. I'm going to rewrite cosecant now using that reciprocal identity, 1 over the sine of t. I can multiply in any order. My sine of t times 1 over cosine t cancels out, and this simplifies simply to cosine t. B, I've got cotangent x cosine x plus cosecant x times sine squared x. So I'm going to start by rewriting what I can. I'm going to use the quotient identity to rewrite cotangent. So that's going to look like cosine x over sine x times cosine x plus cosecant is 1 over sine x times sine x. I can multiply through each. I get cosine squared x over sine x plus, that's a sine squared, plus sine x. I'm going to cancel one of the sine x's in the numerator and denominator. Now I'm going to multiply that second term by sine x, so I get a common denominator. I get cosine squared x over sine x plus sine squared x over sine x. I guess I could have just noticed that there was a common denominator to begin with and not canceled those. I can combine. I get cosine squared x plus sine squared x over sine x. Again, that numerator is 1. 1 over sine x, which is cosecant x. Looking back at my notes, I see I wrote myself a note not to cancel that sine x, but you know, pretty easy to undo something if you need to. So C, let's see, we got secant x plus sine negative x tangent x. So I'm going to start by rewriting everything. Secant is 1 over cosine. Sine of negative x is minus sine x, so I'm just going to rewrite minus sine x. Tangent is sine x over cosine x. I end up with 1 minus sine squared x over cosine x. 1 minus sine squared x, we can take a look at our Pythagorean identity up here. If sine squared x, or sine squared theta plus cosine squared theta equals 1, I can subtract sine squared theta from both sides. And 1 minus sine squared theta is cosine squared theta. Now I can cancel those cosine x's, and I end up with the cosine of x.